Good afternoon, my students. How are you? I hope that you'll be okay and your family also okay. I hope you stay in your home. Today we need to talk about our topics that we need to complete also our topics that we finished before closing the schools. So we need to complete our topics with you, Mr. Chadi Eldib from Tabarak Private Schools.
How are you, my students? I hope you'll be fine. Today we need to talk about the second part in simple harmonic motion. Today we need to talk about the time period for pendulum and spring, and how can we calculate this time period for the pendulum and the spring. So be concentrate, be attention with me. How can we evaluate this time period for the object that did simple harmonic motion? So the pendulum time period formula. Now let's talk about the pendulum time period formula. T equals 2 pi root L over G. Now let's analyze this formula. T equals 2 pi root L over G. T is the time period and must be in seconds. Also L is the length of the pendulum, and G is the gravity. G is the gravity. So from this formula, T equals 2 pi root L over G. We can also find the frequency. As we said it before, that frequency equals 1 over T, 1 over time period. So if we ask you now, what are the factors that the time period of the pendulum depends on? And what is the factor that the time period of the pendulum does not depend on? Now let's check these two questions. It's very important for you. Time period for pendulum depends on, number one, the length of the pendulum. And it's directly proportional. Directly proportional means if the length increases, so the time period also increases. But don't forget that T equals 2 pi root L over G. So time period is directly proportional with the root square of L. Root of L, radical of L. T is directly proportional to the radical of L. Okay, so we can write it in a ratio T1 over T2 equals L1 by radical over L2 for the radical for this value. So I can say also by another way, T1 square over T2 square equals L1 over L2. By the second factor, gravity. As we know that the gravity on our planet on Earth not looks like in any other planets or in moon. So the gravity decreases in moon. So what will happen to the time period? Time period for the pendulum with gravity is inversely proportional. And it's very important to understand this part, because sometimes he can say if we remove or if we take this pendulum and move this pendulum, or if we transfer this pendulum from the earth to the moon, what will happen to the time period? You have to know that the gravity on the moon decreases. The gravity of the moon less than the gravity of earth. But the time period does not depend on the mass of the pendulum. The mass of the pendulum, it's not considered as a factor of factors that depends on or that the pendulum time period depend on. So he can ask you one question in this part and said, if the mass of the pendulum is doubled, if the mass of the bob is doubled, so what will happen to the time period? I think no change. Why? Because the formula doesn't include any mass. Now let's talk about the time period for what? The time period for the mass on a spring. Yes, T equals what? 2 pi root M over K. And what's E? What's T? T is the time period in seconds, and M is the mass of this oscillating body, and K is the spring constant. You have to put it in your mind. It's very important. So don't forget also, sometimes we can say K is the stiffness, represents the stiffness, because we know that iron not looks like copper, not looks like any other metals in stiffness. So K is representing the stiffness of this metal. It's very important. We can find also the frequency by using F equals 1 over T. So the time period of mass on a spring depends on what? The time period of mass on a spring depends on two factors. Number one, the mass of the spring, and it's directly proportional because I said T equal to by root M over K. Number two, the spring constant, and the spring constant K, it's inversely proportional, and we can do it in a ratio. But don't forget that the time period of this spring does not depend on the gravity because the formula doesn't include G. So put it in your mind, T is directly proportional with mass, but T is inversely proportional with the spring constant from the formula T equal to by root M over K. Now we need to study the relation between a kinetic and potential energy in simple harmonic motion. I think all of you know that any object move has energy, and this total internal energy classified or divides into two parts, two main types, kinetic energy and potential energy. So you have to put it in your mind. The relation between the energy and amplitude for kinetic looks like blue graph, and the relation between the energy and amplitude for potential energy, it's red graph. So it's very important to know. It's very important to differentiate between these two graphs. Okay, how can we calculate this energy? It's very important. Yeah, total energy equals half m omega square a square. And we know that what's meant by omega. It's very important. Potential energy and kinetic energy equals half m omega square amplitude square minus x square. Also, potential energy we can find it by using this formula, half m omega square x square. So x displacement, but a is amplitude. So it's very important to know how can we differentiate between these two graphs. Beside that, how can we calculate each one? In front of you now, you have three formulas. One for kinetic, one for potential, PE or EP or U. All of these symbols are the same. Also, total energy, E equal half m omega square a square. This is for total energy. So you have to concentrate. You have to focus on the question. Which part he asked you? Which part he'll ask you? Which part he asks you? It's very important for you to differentiate between the different problems, different points in this question or in these formulas. I hope that you will understand what we explained today. So please study this very well and train in your home. Be in a safe, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you for your listening, and also thank you for your caring for what we explained, and thanks also for the chairman of our school, Mr. Yunus Rahbi, because he did everything related to make this process very cooperative, related to new technology in education and how to process this technology to reach all information to the students. So thank you, and don't forget that the homework also uploaded in model in the website of our school.